Hello everyone, this is Mr. Slomka, and today what I wanted to do is I wanted to talk to you a little bit about the creation of the unit circle. I'm going to make you 5 videos on this, and this is going to be our first one, which is going to be a bit of a short introduction. And so what I have for you right here is I have a big question that's going to help us kind of guide our discussion in the next couple of videos. And so the big question here is, what is the exact value of the cosine of 135 degrees? So right off the bat, the first thing that I would say is, I don't know. I don't know what that answer is. And so the next thing that I might do is I might say, well, if I don't know, maybe my calculator does. And so what I could do is I could type in the cosine of 135 into my calculator. And so if you do that, if you type in the cosine of 135, you will get an answer, but it won't be exact. This is a decimal. If I was going to write this down, I would have to stop writing down digits at some point, and that would mean I would need a round. And this decimal right here goes on, and it's infinitely long, and it's not repeating. So that means that that will be very challenging to write down. So I can't write down negative 0.707. That is not acceptable because of this word exact right here. Exact is going to be a huge deal in this chapter, and we're going to see it a lot, which is also code for throw your calculator in the garbage. So now, this is the next step here. Everything that we've tried so far is a failure, so let's move on to something else. What we need is we need a tool that can quickly give us exact trig values. So we want to be able to get the answer for this very quickly and very easily, and we don't want to have any decimals. And what we want to make sure that this tool is efficient. So I want it to have the most popular or the most special angle measures in it, like 30 or 60 or 90 or 45 or 135. And I don't want to have any extra ones that are not particularly popular. The tool needs to be compact, it needs to be organized, and the battery should never run out. So this is all some really great ideas that will help make our tool. And so let's see if we can kind of dive a little bit deeper. So let's talk about our next piece. So what I have for you right here is I have a picture of a circle. And so a circle is a very nice, compact, and organized way to talk about rotations and angle measures. So what you can do here is you can start on the x-axis and you can rotate counterclockwise or you can rotate clockwise, and you can get a lot of angle measures represented in the exact same picture, which is amazing. It is very efficient, very compact, very organized, which is some of the things that I had said I wanted in the tool. So let's see if we can take this a little bit further. So now this circle is a special one, and it is going to be a special circle because it has 2 major things. First of all, it has its origin at its center point at the origin, which is 0, 0. You can see that right here. And then it also has a special radius. So if you take a look at my scale here, you'll find out that the distance from our center to the outer edge right here is a very nice generic number. It is going to extend all the way out here to 1. That is a fantastically easy number to work with. I bet you're awesome at adding 1 or multiplying by 1 or dividing by 1 because 1 is great. So that's a fantastic radius to work with. I'm going to be more specific than that, and I'm going to call it 1 unit. And I'll speak on that a little bit more in maybe some of the other videos. Next, let's talk about angle measure. So earlier I was talking about popular or special angle measures, and I was talking about 30s and 60s and 45s and 90s and how great they were. I have specifically picked a very unpopular angle measure for this section right down here, 75, and I'm doing that on purpose. So I want you to see what I want to do right here. So a 75-degree angle has been drawn here. So basically what we've done is we've started down here on the x-axis, and we've rotated counterclockwise, which is the standard direction for positive angle rotations, and we've rotated 75 degrees. And that gives us this line right here, which is going to intersect your circle at this point right here. Now, what I want to do with you right here is for step number 3, it says count the dots on the grid to estimate the ordered pair location of that point. So where exactly is this point located? Well, if you take a look, once again, my scale right here is counting by tenths. So it is small. It is a small scale right here, and that's going to work out okay for us. So if I'm moving side to side from the origin out to this point right here, it looks like I need to go past the point 1 and past the point 2 and not quite to the point 3. So my guess would be that it's probably somewhere about maybe 0.25, but maybe a little bit further than that. So let's say 0.26. You could maybe say 0.27 or 0.28 or maybe even 0.25. I'm not quite sure, but I'm going to go with 0.26 or 0.27, something like that. Next, let's talk about the height. So when we're talking about the height right here, we're going to be counting up quite a ways. 75 is a pretty steep angle right there, and so we're going to be extending up pretty high. So right here, it looks like I'm going up past the 0.8, past the 0.9, but definitely not quite to the 1.0. So it's not going to extend up here to the 1.0. So that means that I'm going to be very, very close, but not quite. So once again, maybe 0.95 or maybe 0.96, or I'm going to pick 0.97. I'm going to say that this point right here lives at 0.27 and maybe 0.97. And these are just estimates. They're not perfect. I'm just eyeballing it here, and that's kind of the point. Okay, so next, here's the next thing that I'd like you to do. I'd like you to take a look right down here. So right here, what I have for you is I have a couple of pieces of information that I want from your calculator. So we are kind of abandoning the idea of an exact value right now because I'm trying to focus on some of the other pieces of the tool I want to build. And so what I'm going to ask you to do now is I'm going to ask you to find the cosine of 75 degrees and the sine of 75 degrees. So let's see if we can do that. So if I type that into my calculator, my cosine for 75 degrees is going to be 0.258. If I round that, that would be 0.26. The sine of 75 degrees, if I type that one into my calculator, the sine of 75 degrees is going to be 0.965. Or if I round that one, 0.97. So let's take a look. These numbers that I've just created right here and these numbers that I have right up here are connected to each other in some way, and we need to make sure that we understand that. So it is very clear and easy to see once you look at both of them at the same time. And so you're going to want to do that. So if you take a look at my first value that I had here and my first value that I have here, you'll notice that they're really, really stinking close. And if you look at my second value here and my second value here, you'll notice that they're almost exactly the same. So I did do some rounding here, and I did do some eyeballing here, and so they don't might not look exactly perfect, just like these first two numbers, but they are. They are the exact same. So here is what we're going to do. We've talked about how the circle is compact, and you can represent a lot of angle measures on it. And the other thing you can do for your circle is you can represent cosine and sine values as well. Every x value that we have right here is actually a cosine value, and every y value we have here is a sine value. So that is amazing. Let's write that down here at the bottom of the page. What did you notice comparing your ordered pair in step 3 with the values from 4 and 5? And the thing that I would notice is that every x value is a cosine and every y value is a sine. Okay, so great. This is what our tool needs to look like. It needs to be a compact, clear circle full of popular angle measures, and they're going to have ordered pairs around the outer edge because every ordered pair is going to be a sine and a cosine value. So this is going to give us kind of a goal as to what we need to build. All right, so now this is video 1 of 5. I'll have 4 more videos for you as well.